So in this video, we're going to look at the volume of a cone. So we can see, this is the cone shape down below. So the volume of the volume V of a cone with radius R is 1/3 the product of the base B times the height H. All right, so let's shorten that statement again. So we have 1/3, volume equals 1/3, the product of the base times the height. So now let's go ahead and write it in our formula. So I have V for volume equals 1/3 times the B, which is the base, and the H, which is the height. And again, we need to acknowledge, what does base mean? Well, base means the area of the bottom. So the shape of the bottom here is going to be a circle, and the area of a circle is pi r squared. So now let's replace that with B so that we can have an accurate formula here. So we have 1/3 pi r squared times H. So we're going to take a minute and we're going to compare this with the volume of a cylinder, because we had just done that on our previous couple of videos. We're going to think about it just for a minute. So the volume of a cylinder, that was V equals pi r squared H. So that was when we were doing a cylinder. Remember, that's like a can shape. And the volume of a cone is V equals 1/3 pi r squared H. So the only difference here that I can see is that 1/3, right? Otherwise, they're identical formulas. And what this means is that it would take 3 cones to fill up a cylinder with the same radius and the same height. So they need to have the same radius, they need to have the same height, but it would take 3 cones to fill up that same cylinder. So there's actually a little video here that I'm going to have us watch.
Work out the formula, and we see mathematically that it takes 3 cones to fill up one cylinder that have an equal base and an equal height. Let's go ahead and fill them up with water and see if this actually works out. So here's number 1, as you can tell. There's 1. Let's go again. Here comes number 2. 2. And finally, the last cone, and it should fill up to the very, very top. And here we go. Number 3, 1, 2, and 3.
So he kind of keeps talking about that, but I just liked the visual there. So it's definitely a very interesting concept that it doesn't look like that crazy, difference of a shape, but it cuts the volume by 1/3. Okay. We're going to go ahead and we're going to look at the problem they give us here on Alex. So find the volume of a cone with a base radius of 6 centimeters and a height of 9 centimeters. Use 3.14 for pi and do not do any rounding. Be sure to include your correct unit in your answer. So there's a pretty common set of instructions here. So first, we know the radius, and we can see that down here. I can see the radius. We know the height, right? We can see the height here. We're going to use 3.14 for pi again, and it asks us big instructions here. Do not do any rounding. So you're not going to round anything off. Whatever you have in your calculator, that's what your answer is going to be. And then make sure you include your correct unit. If you don't put the unit on it at the end, your answer will be incorrect. So make sure you're paying attention to that. Okay, so we have our height, we have our radius. Let's go ahead and plug it into our formula here. So 3.14 for pi, 6 for the radius, and 9 for the height. So let's do our 6 squared first, just so to simplify that. So now in our calculator, we're going to go 3.14 times 36 times 9, and we get this nice big number here, 1,017.36 centimeters cubed. So this is the correct unit because it was centimeters to start with, and since it's volume, it's a 3-dimensional space, so it's cubic. All right, so that was volume of a cone. I hope that helped, and I'll see you in the next video.